tutorial, we will add labeling to our primitive fictional parking plan. In Rhino, I have already opened it, and end result will be adding parking places with numbering sorted along the curve how you want it. It will auto renumber itself when you delete lines or add more. So let's begin. First I will delete what I have already have. Okay, so I have already imported curves to the Grasshopper, and first thing to see, we need to check what we have. So add area component to get center points and point list component. Point list to see the numbering. As you can see, everything is chaotic, numbered in whatever. How well I want it, I don't know. So the simplest solution probably is to sort along the curve. So for this we have this component, center points goes to point component, and for curves we need to draw a polyline. Doesn't have to be precise, but it should go near the parking spaces that you want to number. So let's draw a little snake. Doesn't have to be precise, it can intersect itself, doesn't matter. Select the curve, set one curve, and now everything is sorted how we want. If we move the place, it will renumber itself. However, we do not want it, so this is definition, but only the points are sorted. So what we need now is list item component, select indices and curves. Now we have the points and curves sorted. Let's group it and name sorted curves and points. Of course, we do not want numbering to start from 0, so let's use from display tab text tab 3D. For the location, let's use construct plane. The plane will be our sorted center points. Also, let's add really by double clicking on the wire. Now let's name it center point. This will be our location. For text we can use series component. By default it creates 10 numbers, but we need much more. So let's select list length, add it to count, and as I said, we want to start from 1. Select the justification bottom center, connect text size, for maybe better understanding we can use concatenate, maybe add a letter P. So now we have a text that we want, however the location is not exactly what we would need. So for this we want to select the closest edge to our guiding curve. So we used curve closest point component. First explode the curves. We now have 4 segments of each line. and we need to select the shortest ones. So by default in Rhino we probably could select first and the third items. However, if you have exported from another program your plan, it may not be so. So to be sure, sort list by numbers and seconds. Now we are sure that the first two items will be the shortest edge. However, it may not be so that they are the ones that we really need. Maybe it will be on the opposite side, maybe not. So this will be our curves. So now we need to use curve closest point component. We need a point. So for this, let's use point on curve. Let's merge it. Add the points. The curve will be our center point, our guiding curve, I mean. Now we have the points. Sometimes it can select the list will not be sorted in any way. Sometimes the point will be the closest one, sometimes it will be on the opposite side. So we will sort the list again by distance. We will need our points and also our lines. Now that we have this sorted list, let's hide everything. So now we have two curves, which the first one will be the one that is closest to guiding curve. As you can see, it seems correct. And now that we have this line like curve, let's flatten the list, convert it to line, and then we can convert line to vector, and let's deconstruct it. Now that we have x and y components, let's use expression to calculate the arc timing. So write a time 2 y comma x, and we get an angle in radians. We can use this to rotate our planes. So this will be the angle, axis will be line SDL. For the start point we will use again our center points. Direction is D, it's correct. You can add the vector to make sure it's always correct. And objects will be our planes. So now that we have it here, as you can see, everything has rotated. Now maybe we want to move it closer to the edge. Move text closer. So this will be our plane. For the vector, let's duplicate list item from our sorted closest points to the edge, and let's pick it. So, and for we will need a vector for transformation. So let's use vector to point. This we will start from the center point and go to the midpoint of the edge. Here we go. Maybe we want to add slight offset from the text, so we can use multiplication. So in there you have it. This is our text, offset, and rotation. Hopefully this script has been useful. So you can modify the size, change text, offset by using this. You can modify the curve to set slightly so it won't break where you don't need. And that's it. Hopefully it will be useful.